Hello, my name is Brian Toe, and this is my lab report for Lab 5, and for this I did a lab on a Slinky in motion. Within the lab, we observed the motion of a Slinky from a lab video and recorded its data through Tracker. The reason for doing this was to observe this motion in order to compare it to the modeled motion of the Slinky within GlowScript. Then, we compared the two datasets, or models. Different principles and forces that are involved in this are the definition of the system as Earth in the Slinky, Newton's second law, gravitational force, drag force, tension force, velocity update, position update, and then all of these formulas and equations are listed here, and the different variables are also defined here. This was the original video that we had to work off of for the Slinky. And as noticed in this video, the bottom of the Slinky didn't fall until the top of it met up with it, and then they both fell together towards the ground. This is the data on the left is data from Tracker that we fed through the video, or fed the video through rather, and that goes as following. And this really tracks the position of the bottom of the Slinky in order to really plot out this trend of, or this motion that the bottom, or rather lack of motion that the bottom of the Slinky had in not falling until the top met up with it. And on the right is GlowScript data, which is sourced from a model we created using GlowScript. And the code for that is as showing, or as following rather. These are some of the initial conditions of the system and model. And this first while loop is to model how the bottom of the Slinky behaves and before the top reaches up or catches up to it, and that is that the bottom of the Slinky does not move yet. And then the second while loop is to model what the bottom of the Slinky does when the top does catch up to it. And this illustrates a fall towards the ground together. And that model looks as shown here. And so these are just the model data and the observational data. Some possible errors in this before I go into the analysis of the data is that there could be errors in auto tracker points that are picked up, and not all forces being possibly included, for which could account for this jagged bottom motion rather than a smooth line. However, even with these possible points of error, the overall graphs are rather similar, and they showcase this overall trend for the bottom of the Slinky to not really move until the top catches up with it, which was about just after 6 seconds. And so that allows us to reach the conclusion that the bottom of the Slinky stayed at rest until it dropped. And this was because tension and gravitational force cancel each other out until that top of the Slinky finally met up with the bottom and they fell together. This was my lab, and thank you.